So coming to the example which we have left earlier. So here for utility approach, the similar example we have taken what we have discussed in the previous lecture also, that material selection with the different alternatives are available with cast iron, ductile iron, SG iron, cast alloy steel, hardened steel, surface hardened steel, carbonized steel, nitride steel, and hardened carbon steel, with a different criteria of core hardness, surface fatigue limit, bending flattening limit, and UTS, that is the ultimate tensile strength. As a similar criteria, we are assuming that lower is better of core. This is core hardness. Core hardness we have taken as the lower is better criteria. So this is for lower is better criteria, and rest of the things are for, again, the higher is better. Now we will analyze the same thing using the different method, that is utility approach, as discussed the theoretical part earlier before lunch. So here we will try to normalize the data using the utility method. So here the first thing we will try to find out what is the best value and what is the worst value for that, or the acceptable value of that. For that value of CH, core hardness minimum is better criteria. That is why the minimum value will be considered as the best value. So here you can see the 185 here, that will be used as a minimum value. So minimum value will be considered as the best value here. And out of this, if you see, the worst condition what we are getting is, I think this is 315. So 315 is the maximum value will be considered as the worst value, or the just acceptable value for core hardness typically, right? And this is applicable for all the alternatives. So core hardness having 185 as the best value and 315 as the just acceptable value for first criteria. Coming to the second criteria, that is surface hardness. In a similar way, you can see the maximum is better condition. So 750 is the maximum value, will be considered as the best value for surface hardness, and this is 185 is minimum. This is the worst value, will be considered as a just acceptable value. Similar to that, SFL you will get 1500 is the maximum value as best, and 330 is the minimum value, is the worst value considered as a just acceptable value. Similar to that, you will get 920 here as the best value, and 100 is the worst value for this. And here it is 2300 is the highest value, and 380 is the worst value we are considering. So these are the just acceptable values. You do not have any choice out of that, and these are the best value for different criteria. Now if you have the just value and best value for this, now you can see these are the best value for different criteria: core hardness, surface fatigue limit, bending fatigue limit, and ultimate strength, tensile strength. An acceptable value is this. Now you can calculate the value of A for individual cases. And this A is applicable for individual criteria, not vary with respect to the alternatives. So if whenever we are dealing with the core hardness, the A value will be same for all cases of all alternatives, right? So when we talk about CH, minus 38.93 will be the value of A. And how you are calculating the value of A? A will be equal to 9 divided by log of x divided by x star divided by x I days, where x is the best value, x star is the best value, and x I days is the just acceptable value or the worst value.
Sir, right? A small doubt, sir. Hello, sir. Is the 9 because of number of alternatives, sir, or?
No. This 9 is the constant value.
Constant variable. Okay.
Yes.
Incidentally, it is 9 here, so I got it out whether it was based on the 9. No.
There is no relation between that. That is relation itself is a constant value of 9. The reason behind that is the behavior of this method is logarithmic behavior will be shown, right? So that is why it is between 0 to 9. And if you see carefully in this slide, it is written u value is varies between 0 to 9 maximum value, right? So ये हमेशा 9 ही रहेगा, आप कितना भी alternatives हो, don't worry about it, right? Is that clear?
Yes, sir. Yes, sir.
Fine. In the similar way, you will find out the value of A for different criteria. All the criteria you can find out the value of A. Now you can see the value of acceptable value is the best value is there, acceptable value is there, and A is there. Now you can find out the preference number or utility index for individual alternative and criteria, right? For alternative, individual alternative and criteria, you will find out the value of PI, that is called as preference number or utility index. And this is somehow, you can say, another form that it is a normalization of data, as we have discussed in other two methods. First method, normal normalization, we have done by higher and better and lower is better criteria. Second method, based on the desirability approach, we have take the target value, and based on that we have decided the value, we have calculated the value of DI, and DI, by calculation of DI we can have a table that is, again you can say it is a normalized table. In this case, we are trying to calculate the value of preference number or utility index, and we will find out the complete table. That table will be, again you can see it, a normalized table in a single scale. So ultimately what we are doing in case of any MADM technique, we are trying to convert the data available, actual data available in a different scale to a single scale, right? Earlier we have seen the scale was varying from 0 to 1. Here the scale will be varying from 0 to 9, correct? So here PI can be calculated. PI will be calculated by a relation of A is equal to log of xi divided by x mean when we are taking higher is better criteria, right? So x mean, xi and A. So if you are talking about higher is better criteria, this is the condition. If you are talking lower is better criteria, then it will be A multiplied by log of xi and x maximum, right? Let us try to find out the first value. First value of this data, we are trying to find out the preference number with respect to cost iron along with the core hardness, means ye wala xij you can say. So if you are trying to find out this value, so what you will have, the equation says this is the condition for lower is better, right? This condition for lower is better, core hardness. So we have the A value, so we have minus 38.93 here, log xi is what? 200, correct? Xi is what? 200 we are taking. Just a minute. Yes. Xi is 200 here, and the value of x maximum. So this is the value of xi. X maximum, you can say x maximum is coming 315 in two places. Need not to worry anyway. So 200 xi, x maximum is 315. A value will be taken from here. So A value is this. So we'll use this equation and you will get a particular value called as 7.6819. Can you just calculate it for short this one? Are you getting this or not? A value is given minus 38.973 log of xi is 200 and x maximum is 315. We'll considering the criteria of lower is better for core hardness.
7.681.
It's coming now.
Yes,
7.681.
681. Yes.
Correct. In the similar way, you will find out the second data, that is with respect to the surface hardness. So here in surface hardness, we consider that higher is better is the desirable criteria. For desirable criteria, you need value of A. We are trying to calculate PI. Now A value for this SH value, it will always be 14.80 for all alternatives. Then xi for particular case is 200, and the value of x minimum is this x minimum. When we use x minimum will be in case of higher is greater than. Is that clear? So using these you will get the another value, that is 0.51 0.501282. This is the another value of UI, the utility index or preference number, with respect to the first alternative and second criteria. Similarly, for third, fourth and fifth criteria for first alternative can be calculated, and respectively you can calculate for 2, 3, 4, 5, 6, 7, 8, 9 criteria. So all criteria will be used here, and you have the prepared value of the preference number or utility index for individual criteria along with the individual alternatives. Now somehow if you see carefully, all the data you are getting here is the value of close to 9, this value is 9, right? This value is 0. Now you can see the variation what we have seen in earlier case was 0 to 1. Now it is shift to 0 to 9. Now it's clear?
Yes, sir.
Coming back to the another way, means now you are trying to you have to calculate the aggregate value of overall utility, and again it will be the summation of the weightage along with the preference number. These are the basically preference number, right? These all values are the preference number with respect to individual. Now first value of U, overall score or overall utility, will be calculated based on the alternative. So with respect to this, we will find out what is the overall utility index for alternative 1. Using alternative 1, so it will be, if I am giving the equal weightage to each, so 20% weightage will be given to individual criteria, right? So W1 P1 is this, W1 P1 plus W2 P2 plus W3 P3, W4 P4 plus W5 P5, and summation of this will give the overall value of the utility, right? But it is not restricted to give the equal weightage. Individual decision maker can give the weightage to different weightage to different criteria. Like I want highest value of the effect or sensitivity of surface hardness is more, so I can give 30% weightage here, right? And I am finding okay, I don't care about this one, I'm least bother about, so I can give 10% here, maybe I can give 40% here, somewhere I can give 5% also, right? So that can be given by the decision maker, and decision maker will decide based on the what application we are using, what is the desirable or the actual requirement for particular case. Am I clear? So this WIPI, if nothing is given, nothing is known about, you can give the actual value, equal value of weightage. If you have a clear cut idea that which has to given the higher weightage and which has to given the lower weightage, then you can vary or play with the weightage as a decision maker. Using this criteria, now you can find out the value of overall index for individual case. So alternative 1 to 9, we have calculated the overall index, utility index for each cases, and we can rank the highest value as value of first rank, and corresponding the lower value will be ranked subsequently, and lowest will be considered as the last value. So 1 to 9 the ranking will be done. If you will observe carefully, all three cases, almost we are all two cases where I have taken the same example, we are getting the same answer as 7 is the best rank, the first rank for this case. Now it is clear?
Yes, sir.
Can you just think about it कि आपने utility approach पढ़ लिया, आपने सामेथक पढ़ लिया, आपने desirability value पढ़ लिया, right? In all cases we are trying to rank the alternative available. अब इसके बाद हम कहते हैं इसमें टागुची लगा दो. कैसे लगाओगे? think about it, DOE plus Taguchi plus any of these method, how you can use them. Think about it, कैसे इसको यूटिलाइज करोगे? सी अगर आप इस मेथड को लेके चलते हो किसी जगह पे, किसी आपके रिसर्च वर्क पे या जो भी आपका प्रोजेक्ट वगैरह है, right, and you have shown this one will not be given the significant appreciation or not appreciated by the editor or the reviewer, right? Whenever you apply these along with the design of experiment and Taguchi approach, you may get better result and as well as better appreciation in terms of the quality of work. Now see, we have learned about how to rank the data alternatives, right? How to apply this in terms of BI. आपके पास raw data कहाँ से आएगा? आपके पास वो decision matrix कैसे तैयार होगा? Are you getting my point? कहाँ से आएगा आपके पास raw data?
Experimental works?
Of course. Experimental work को आप शॉर्ट करने के लिए यूज करते हो डिजाइन ऑफ एक्सपेरिमेंट, राइट?
Yes, yeah, we'll start with design of experiment.
Design of experiment. Now set of design you will prepare, right?
Yes.
Set of design you will prepare like L25 orthogonal array or L16 array, whatever you are selecting based on the how many number of
levels and
parameters and labels, है ना? Levels, है ना? So m into n के basis पे आप select करते हैं, ये short the experiment number, cut out the number of experiment. After doing this experiment, you will have a response as an output of individual parameter. Yes or no? Right?
Yeah, we'll have. Yeah.
So these data will be used as a decision matrix. Correct? Now, what are the alternatives over here? Alternatives are the number of experiment here. Yes or no? It's not a product, it's a process, right? So आपके पास आपने suppose L25 array आपने follow किया, आपने array L25 orthogonal array आपने use किया, so you had 25 sets of experiment, yes or no? And 25 sets of output response multiplied by how many factors, right?
Yeah.
Whatever be the factor number. So now these all factors and the responses, that table will be used as a decision making table or decision matrix. Now that table will be used to use for the applying this multi-criteria decision making or multi-attribute decision making, and there you will find the rank of the data, rank of the output. तो ये जो आपके पास U टेबल, U वाला जो आपका ओवरऑल फैक्टर आया है और यहाँ से आपने रैंक किया है, आप उस डेटा को यूज करोगे तो ये मिलेगा कि नहीं मिलेगा? 25 के लिए 1 to 25 का रैंकिंग मिलेगा कि नहीं मिलेगा?
Yeah, we'll get it. We'll get the rank.
After that, if you remember, while discussing DOE problem, Taguchi method, there was a method of finding SN ratio. Yes. So वो SN ratio की जगह आप इसको पुट कर दो सीधा. जो आपने SN ratio का टेबल लेके आप रिस्पॉन्स निकालते हो, उसकी जगह आप सीधा ये पुट कर दो उठा के. And then the process will be same as previous what you have done. Ultimately, by using this different method, what we are trying to find out? We are trying to find out the SN ratio. If you remember, जो SN ratio का टेबल आता था जिसमें C1, C2 आपका रिपीटेशन करके फिर एवरेज लेते थे, फिर SN ratio कैलकुलेट करते थे, उस रिस्पांस की जगह पे या सीधा आपका जो दो रिस्पांस आता था C1 टेबल एंड C1 C2 कॉलम, राइट? वो SN ratio को छोड़िए, आप C1 C2 के बाद एवरेज करते थे C1 C2 का, उसकी जगह पे इस वैल्यू को आप पुट कर दो, आपको SN ratio निकालने की जरूरत नहीं है उसके बाद. Are you getting my point?
Yes sir, yes sir.
Yes.
वो डेटा रख के ये डेटा जो आपके पास आया उस डेटा को यूज करिए, देन फाइंड आउट द मीन टेबल फॉर इंडिविजुअल फैक्टर विथ इंडिविजुअल लेवल, एंड देन प्लॉट द ग्राफ, रिस्पांस ग्राफ, एंड वेरेवर द हाईएस्ट वैल्यू यू आर गेटिंग, and that value will be taken as the best combination, right? Ultimately हम क्या कर रहे हैं, जो SN ratio वाला steps है उसको eliminate कर रहे हैं इसके लिए, and better accuracy आपको मिलती है इससे, और आपका क्वालिटी ऑफ वर्क भी बेटर हो जाता है। तो ये कॉम्बिनेशन ऑफ DOE अलॉन्ग विद द MADM टेक्निक, राइट। आप डायरेक्टली DOE से भी वो डेटा निकाल सकते हो जो डेटा आप इससे निकालते हो, राइट। So this is the use of the method for MADM technique. Now coming to the next, यहाँ तक कोई डाउट है, कोई प्रॉब्लम है? Should I go ahead?
Yes, sir.
Fine. So now I'll start with the last one for today's session, that is gray relation. Right. I'll just stop sharing. I'll share the another slide. My slide is visible?
Yes, sir.
Fine. So, yeah, this is another method that is called as gray relation analysis. Is one of the important and popular method for MADM technique. Name itself indicate the gray relation. What does it mean? अगर आप देखो जो हमने मेथड अभी तक पढ़ा है, 100 मेथड पढ़ा आपने, you have gone through the desirability approach, utility function. What we have found during the normalization table, we got certain value as 0, right? Significantly places we have found at least 110 तो आपको सब जगह मिली है, right? What is 0 indicate? That is saying is useless. There is no meaning of that. Does not contain any kind of information. And disturbance is there. Am I audible?
Yes, sir. Yes, sir. Yes, sir.
So this 0 does not means that doesn't carry any information. It doesn't have certain value. While normalization we are getting 0, and it is coming at the place where the value is minimum, right, or maximum, or in a different term you can say the value which is worst as compared to the desirable value, right? That point becomes 0, but it is having a significant value, right, which has certain meaning. So it means what, जो 0 आपने रखा हुआ वो 0 का क्या वैल्यू है, क्या उसका रिलेशन है, दैट हम फाइंड करने की कोशिश करते हैं ग्रे रिलेशन एनालिसिस में, जो कि आपके बाकी एनालिसिस में आपको इंफॉर्मेशन नहीं मिलती है. Name it say indicate gray relation means some relations or some factors or criteria doesn't have the value which is known, or information is not known, so which will be unknown variables, and some part is having the significant known value and some part is having partial information. So ये 0 जो है आपका partial information देता है, वैल्यू तो है बट वैल्यू दिखती नहीं है उसमें. सो ये जो है ग्रे पार्ट होता है जहां पे आपके पास पार्शियल इंफॉर्मेशन होता है. तो हम इस पे रिलेशन फाइंड करने की कोशिश करते हैं. विल ट्राई टू एलिमिनेट दिस 0 वैल्यू फ्रॉम द नॉर्मलाइज्ड टेबल एंड विल हैव सेपरेट सेट ऑफ नॉर्मलाइज्ड टेबल फॉर फर्दर एनालिसिस, and further we will calculate the value of gray relation coefficient and ranking the data. This is what the basic concept of gray relation analysis. It is most widely used in the research papers. You will find so many papers on gray relation analysis nowadays. Now, so theory behind that, basic theory, as I said, there is input and some gray variables, right? So what you will get here, if you are giving some amount of input, right, this and some gray variables are there, the information will be generally divided in 3 categories. One is the known information, another is the unknown information, and in between there are certain value is having the certain variables is having the partial information. So that will be connected with the gray numbers, right? And finally, what you are getting output and hello. My voice is clear and clear.
Yes, sir. Yes.
Fine.
Yes, sir. Yes, sir.
Some gray numbers are there, and finally we will get some output along with the gray variables. So we'll try to get the relation between these gray variables along with the input and output, right? So here the concept is some uncertainty systems are there, some incomplete informations are there. We'll find out the relation with the analysis, and we'll do modular system. We'll identify the key parameters finally and predict the behavior of the data as a decision making. This is the basic concept of gray relation. Some related terminologies are there. Grayness. Grayness means what? Information is incomplete or unknown. Gray element, an element from an incomplete information or message, that will be considered as a gray element. Gray relation is the measurement of changing relation between two systems or between two elements that occurs in a system of time, system over a time. किसी कोई भी दो सिस्टम जो आपके दो एलिमेंट्स हैं या दो वेरिएबल्स हैं उसके बीच जो भी रिलेशंस आते हैं that will change accordingly. Gray relation analysis will give a degree of similarity or difference. Degree of similarity or difference of developed trend among the elements to measure the relation among the elements. जो आपके रिलेशन इसमें अल्टीमेटली क्या करें, जो एलिमेंट्स आपके ग्रे रेंज में आते हैं उसके साथ क्या रिलेशन है उसका ट्रेंड बताता है कि whether it is having the similar element or difference we are getting. The steps of gray relation analysis is response measurement. So the response we are getting from again the DOE, design of experiment, whatever the response we are getting, these responses will be normalized by using the gray relation analysis, right? And then we'll find out the individual gray relation coefficient. One more steps are there in this particular method, and then we'll find out the gray relation index overall, and then we can proceed toward the Taguchi optimization, right? So now you can see we are now in position to connect the first lecture to till date, right? So what we have studied as of now is this part, and this two part has already been discussed in previous lecture yesterday. Now we are trying to connect a complete cycle with a response measurement based on the design of experiment. Then this response will be normalized using the MADM technique, any MADM technique. If you are going for gray relation, then gray relation coefficient has to be find out. Then this overall coefficient has to be find out. This can be used any method, right? This part can be done by any MADM technique. Then finally we will go for the Taguchi optimization. That is what you had discussed. We had discussed in terms of SN ratio and the average value of calculation. And based on that, the response has been plotted, and overall the combination for the best result was discussed earlier. Fine. So these are the steps of gray relation coefficient. Pre-processing of data, there are few extra steps are there as compared to previous method. First, normalize the random gray data with difference measurement unit to transform them in dimensionless parameter. Is somehow you can say it is simply a normalization of data, and that will be within the range of 0 to 1 normalized data, right? So here the normalization will be done in two steps. One is the simple normalization what we have done earlier. and then it will be converted to Gray relation coefficient, and the individual Gray relation that will give the another normalized data. But the first normalized data is between the 0 to 1, but second normalized data you will never get 0 using the Gray relation. This is the important point. So ये जो आपका 0 to 1 आता है, ये आपका normalization जो आपने पहले किया है वही मेथड है, right? उसके बाद हम Gray relation लगाएंगे तो you will just eliminate the value of 0 and corresponding all the value will be changed. There are two criteria as we have discussed, that is lower is better criteria and higher is better criteria. For lower is better, Yij can be calculated as Xij, maximum of Xij, minimum of Xij minus maximum of Xij. This is lower is better criteria. Higher is better criteria, you will find Xij, X minimum divided by X maximum minus X minimum. So this is Xij, Yij for both cases, right? So higher is better, lower is better criteria you can use, and you will find out the data in terms of normalization. Now we'll go for the calculation of individual Gray relation grade. Individual Gray relation grade can be calculated using this. This equation says delta mean plus tau delta max divided by delta 0 ij plus delta max, tau and delta max. What is delta mean here? Delta mean means what? Minimum difference of two normalized table, two data of normalized table. अगर आपके पास डेटा है उसको आप एक दूसरे से माइनस करते हैं तो डिफरेंस मिलेगा आपको, और डेल्टा जो मिलेगा आपको तो मिनिमम कहाँ आएगा? दो कंडीशन में डेल्टा मिनिमम आएगा आपका नॉर्मलाइज्ड डेटा में. अगर आप 0 से 0 को माइनस करोगे तो डेल्टा 0 आएगा, और 1 से 1 माइनस करोगे तो 0 आएगा. Am I clear or not? Right? And for any normalized data, in simple cases, you will find all criteria is having 1 0 and 1 1. Am I clear? जितने भी हम सिंपल नॉर्मलाइज करते हैं उसमें एक 1 तो आना ही है और एक 0 आना है, फिक्स्ड है, राइट? एंड if you want to take a difference of any relation, कोई भी किसी के साथ भी माइनस करते जाओ तो एक फेज ऐसा आएगा जब आपके पास डेल्टा मिनिमम वैल्यू मिलेगी, एंड दैट इज ओनली पॉसिबल व्हेन 0 को 0 से माइनस करो या 1 को 1 से माइनस करो. दिस इज द मिनिमम क्राइटेरिया, राइट? एंड मैक्सिमम क्राइटेरिया सेज 1 and 0, सो 1 और 0 का माइनस मैक्सिमम क्राइटेरिया. तो ये आपका डेल्टा मीन क्या हो जाएगा? 0, एंड डेल्टा मैक्स क्या हो जाएगा आपका? 1, right, in normalized table. And tau is the constant that will be normally taken as 0.5 for majority of the cases. Coming to this one, the value of delta 0i is nothing but it is delta maximum what you are getting, right, in the value of xi minus the xij, right? So this is the value of maximum value of xij, x maximum minus the value of xij, right? And rest of the things are fine. Tau value is normally taken as 0.5. This is 0.5, right? Now, once you have the value of delta ij for individual cases, you can go for the overall Gray relation. This is again similar to, एक बार आपने Gray relation coefficient ये find कर लिया, फिर आप वही weighted average के साथ multiply करके निकाल सकते हो. कैसे निकालोगे इसको? वही आप ये यूज करने के बजाय आप रादर ये यूज करिए wi gamma ij. This is the better way of doing, because the value of weightage can be different. This is applicable when equal weightage is given. Rather, in more general form, you can use this one, right? So wi gamma ij, where weightage can be given equal or different, the answer will be same, right? So this is to calculate the overall relation grade. Once ये grade आपको पता चल गया तो आप फिर ranking कर लो उसको R1, R2, R3 के basis. Was talking about the delta ij is a modulus form of yij minus gi, जो मैंने आपको बोला कि first जो response है उसके corresponding और maximum value के corresponding आपको difference लेना है. ठीक है. Tau is generally vary between 0 to 1, but most of the cases we take 0.5, which is applicable for most of the cases in general. This is one example for calculating the for using the grade relation coefficient. There are one process is there where the circularity at the inlet is given. Exit में circularity कितनी दिया है, thrust कितना लग रहा है, torque कितना लग रहा है. ये चार conditions है आपके पास, चार criteria, and there are n number of experiment, that is 9 experiment has been conducted. These are the data available as a decision matrix. Right? Now you will normalize the data first. So the first is we will try to normalize the data here.
Sir, we lost your audio. You're not.
Now?
Yes, sir.
Okay. So this is example where the circularity at inlet, exit, thrust and torque are the four variables, four criteria along with the 9 sets of experiment has been conducted, and we are having the decision matrix data here. Now we'll try to find out the data normalization using the higher is better and lower is better condition. So higher is better and lower is better condition में अगर आप जाते हैं तो ये देखिए आप इसमें ये क्या है, मिनिमम है, राइट. सो मिनिमम से मिनिमम का आप माइनस करोगे y माइनस y मिनिमम, सो ये 0 आएगा आपका लोअर इज बेटर क्राइटेरिया, राइट. सिमिलरली हायर इज बेटर क्राइटेरिया आप इसको लेंगे, आपका क्या है, आपका थ्रस्ट कितना आ रहा है, पावर कितना आ रहा है, दीज आर द हायर इज बेटर क्राइटेरिया, right. You can have now the normalized table. I am not going much detail in this. You can do this or not. Can you prepare the normalized table using this equation?
Yes, sir.
Yes, sir.
We are doing from starting, right? So we are having this one. Now यहाँ से आप grade relation table start करो. Grade relation में आपको क्या करना है, सबसे पहले आपको निकालना है delta max and delta mean, right? Delta max क्या आएगा, as I have discussed, ये आपका 1 है और ये 0 है, दोनों का डिफरेंस क्या आएगा आपका 1. बाकी किसी के साथ ही माइनस करोगे किसी को तो आपको डेटा 1 के ज्यादा नहीं आएगी डेल्टा, यस और नो, राइट. यहाँ पे भी 0 और 1, यहाँ पे भी 0 1, तो मैक्सिमम वैल्यू ऑफ डेल्टा इज 0 to 1, so is coming as 1. So delta maximum is 1. And delta minimum is possible only when either 0 to 0 के साथ माइनस करें या 1 को 1 के साथ माइनस करें तो आपको आएगा 0. So delta minimum आपका आएगा 0, right? And delta max आएगा आपका 1. So delta max and delta mean is known to you, and use this relation. Now delta mean is 0, delta max is 1, tau is considered as 0.5, and delta 0 ij is what? Delta 0 ij for this case, suppose इसकी बात करें अपन, तो delta 0 ij क्या हो जाएगा आपका 1, maximum value of delta minus this value, that is 0 here. This will give the value of delta 0 ij. तो आपको क्या मिला, 1 minus 0 here, so this will become 1 plus tau and delta maximum. So tau is 0.5 and is equal to 1. Now if you solve this, what you will get, this data will give you, if you write the full equation, you will get gamma ij, right, is equal to delta maximum is what? Delta minimum is 0, right? Plus tau is 0.5 multiplied by delta max is 1 divided by delta 0 ij is 1 minus 0 plus tau is 0.5 multiplied by delta max is 1. Ultimately what you will get here is 0.5 divided by 1.5, and what value you are getting is 0.33. Now अब देखिए आप, ये आपका इंडिविजुअल ग्रे रिलेशन आ गया. अब ये जीरो को क्या रिप्लेस कर दिया आपका 0.33. Am I clear? मीन्स जहां जीरो का आपका ग्रे था सिचुएशन, जहां इंफॉर्मेशन आपका पार्शियल था, नाउ वी हैव ए क्लियर कट इंफॉर्मेशन दैट वी आर हैविंग द वैल्यू ऑफ 0 एज इक्वल टू 0.33. Am I clear? हेलो.
Yes, sir. Yes, sir.
So ये 0.33 आ गया. Similarly you can go for 0.732. So 0.732 जो होगा आपका कहाँ, ये वाली जगह पे 0.732 आ जाएगा आपका. Rest of the things are remain same. You will get different value. If you keep 1, so ये आपका 1 minus 1 0 हो जाएगा. तो 0.5 divided by 0.5 again will become 1. Right? In this way you can have the whole data as transformed as gray relation data. So now you have the gray relation coefficient individually. For this case, you will get 0.33 here, 1 here, and other values are here. Keep in your mind, while calculating the value of gray relation, there is no concept of lower is better and higher is better, because we have already converted the actual experimental data to the normalized form. Once the data has become normalized form, there is no concept of lower is better and higher is better. You directly use whatever the values are given, and there is one single equation to find out the gray relation coefficient for this case. Is that clear?
Yes, sir.
Fine. Once you have this value, now you can find out the overall gray relation using the same method. We are giving the weightage of W1 here, weightage of W2 here, weightage of W3 here, and weightage of W4 here. It can be different, it can be same. In this case, if I am taking the same value of that, then it will be W1 gamma 1, W2 gamma 2 plus W3 gamma 3 plus W4 gamma 4 will give the overall relation for overall gray relation coefficient for alternative 1 or experiment 1. Similarly for experiment 2, 3, 4, 5. In this way you will get the overall coefficient here. This can be used in terms of weightage. यहाँ पे आप weightage ले लो, उसको हटा दो. Better is generalized form, right? So यहाँ से आप rank करके आप देखोगे तो what you are getting the highest value is this one. This is rank 1, right? So ये आपका ranking इस तरह से आप कर, sorry, not this one. I think this is rank 1, right? Am I clear? अब इस रैंक को उठा के आप बीओई के कॉन्सेप्ट में लगा सकते हो टागोची मेथड से. ठीक है? तो ये आपका this is the method of gray relation coefficient. Any doubt up to this? It's fine. Any question or any query? Okay. Now, let us. I'll share you one paper here, which will help to understand. How to apply this type of problem or this type of method in research level, right? I'll just share you one paper. It's a very reputed paper which will be used in different applications, right? So share it. It is, yeah. Is visible?
Yes, sir.
Yeah, gray based Taguchi method. Now you can see the combination कैसे combine किया गया है. Gray based Taguchi method for the optimization of bed geometry of submerged arc bit on plate welding, right? Here they have considered L25 Taguchi arrow for design of experiment. This is the first steps. First design the experiment using L25 arrow orthogonal array, and by using this orthogonal array you can see there are 25 sets of experiment has been designed. Now this experiment is clear here. In this table you can see table number 2, right?
Yes.
This table number 2, here they have used 5 parameters, operating parameters. One is the this list and range is given here. One parameter is voltage, transfer speed, stick out, wire fire feed rate, and creep feed. These are the 5 parameters considered here, right? And units are different, like you can see voltage centimeter per second, centimeter per second, centimeter per second, and there are 5 level along with 5 factors, right? So 5 factor इन्होंने define किया है यहाँ पे 5 levels and 5 factors. So these are the 5 factors and these are the 5 levels they have decided for this. And this is a creep feed is given as a alphabetical manner A B C D like this. So इस condition में इन्होंने L25 array design किया, and will considering they are considering, just I'll tell you what the data is taken as. They have used the output parameters, different output parameter for this. So here using this data of experiment L25 array, they have designed the experiment and performed the experiment. After performing experiment with these parameters, operating parameters, they got the response table. This is the experimental data. So now this experimental data will be used as a decision matrix. Am I clear? These are the output parameters. जो आपने पहले टेबल देखा वो input parameter का था. These are the output parameters as a response of the design of experiment जो हमने किया, और इसका experiment का response आपको ये मिला. ये response आपके पास आया क्या? Bid width हो गया, reinforcement हो गया, penetration हो गया, depth of hazard. For desirability is concerned, the bed width, reinforcement and depth of hazard, this should be lower is better, and penetration should be higher is better. These are the criteria. And this will be, of course, those who are performing the experiment involved in a particular case can only decide that which one is lower is better and which one is higher is better, depending upon the system performance and requirement. Correct? So now once we have this set of data, these data will be used as a decision matrix data. This data will be used and we'll apply the gray relation coefficient here. So gray relation method आप apply करिए इसके ऊपर. अप्लाई करोगे तो आपको सबसे पहले क्या मिलेगा, क्या निकालना है, इसका आपको नॉर्मलाइज करना पड़ेगा, राइट? तो यहाँ पे आपको डेटा नॉर्मलाइज करना है पहले. जस्ट आई विल चेक इट. या okay, they have not given the normalized table. They have directly calculated the gray relation generation coefficient. तो डायरेक्टली इन्होंने 2 स्टेप में किया है. डायरेक्टली ये ग्रे रिलेशन कोफिशिएंट का टेबल आता है आपका. You have to do the normalization of table by using simple normalized value, normalized equation जो आपने पहले किया हुआ था, higher is better and lower is better केस के लिए. Can we do the normalization of the data?
Yes sir, yes sir.
के पास रिस्पांस टेबल है, आप नॉर्मलाइजेशन कर सकते हो ना, हायर इज बेटर लोअर इज बेटर कंडीशन में.
Yes sir, कर सकते हैं.
एंड ये दो कंडीशन है, आपको सिर्फ समझना है कौन सा लोअर इज बेटर एंड कौन सा हायर इज बेटर है. तो यहाँ पे ध्यान रहे, ये हायर इज बेटर है एंड बाकी लोअर. एंड देन ग्रेड रिलेशन कोफिशिएंट निकाल लो आप इसका. ग्रेड रिलेशन कोफिशिएंट जो हमने मेथड बताया उससे निकालो, आपको ये टेबल एज इट इज आ जाएगा, राइट? ये जो टेक्निक्स हमने बताया सिर्फ वही यूज करना है, कुछ और करने की जरूरत नहीं है, इजीली आपका ये आ जाएगा। थोड़ा सा इन्होंने 2 स्टेप बढ़ाया है, जो हम डेल्टा आईजे को पहले उन्होंने अलग से कैलकुलेट किया है, ये आपका ईच परफॉर्मेंस कैरेक्टरिस्टिक को अलग से रखा है। डोंट गो लाइक दिस, सीधा सीधा डेल्टा आईजे भी कैलकुलेट मत करो, आप सीधा फार्मूला में रखो, यू विल गेट दिस टेबल डायरेक्टली, नो नीड टू गो फॉर एक्स्ट्रा टेबल। करेक्ट? नॉर्मलाइजेशन टेबल लो, फिर ये ग्रेड रिलेशन कोफिशिएंट डायरेक्टली कैलकुलेट कर लो, और ये कैलकुलेट करने के बाद आप ग्रे ग्रेड निकाल लो इसका ओवरऑल कोफिशिएंट, ये आपका ओवरऑल कोफिशिएंट आ जाएगा। ठीक है? Once we got this one, we can do the ranking simply. or यहां से इसको कॉपी करो, you take all the grade relation grade for 1 to 25 method and आप इसको यहां डाल दो, इसके जस्ट बाद आउटपुट में, इसके करस्पॉन्डिंग लेवल 1, लेवल 2, लेवल 3 का एक कॉलम बनाइए और यहाँ पे आप एंटर कर दीजिए उसको, जो आपका करस्पॉन्डिंग आउटपुट वैल्यू है एज ए ग्रे रिलेशन कोफिशिएंट, ओवरऑल कोफिशिएंट, राइट? अब आपके पास जो डेटा आप टागोची में लगाते थे कि लेवल 1, लेवल 2, लेवल 3 के बाद आउटपुट रिस्पांस के बाद एसएन रेशियो वगैरह निकालते थे, वो करने की जरूरत नहीं है, डायरेक्टली ये वैल्यू लो। ये वैल्यू उठाने के बाद आप इसका एवरेज वाला टेबल निकालिए, मीन टेबल जो आप निकालते थे। और मीन रिस्पांस टेबल कहां से निकलता था, आपको अगर याद हो, आई विल टेल यू, मीन रिस्पांस टेबल इस तरह से बनेगा, याद आ रहा है? जो आपने कल टागोची में सीखा है, तो इस तरह से लेवल 1 का मीन, लेवल 1 का मीन विथ वी, राइट? वी वोल्टेज है आपका, सो वी वोल्टेज के लिए आप मीन कैसे निकालोगे, लेवल 1 का मीन, लेवल 1 विथ वी। तो ये देखो आप 1 1 1 1, ये जो है वेन कहां मिला है आपको, ये 5 डेटा में मिला है, राइट? ये जो है आपका, ये 1 to 5 में आपको 1 1 1 लेवल मिल रहा है, राइट? 1 to 5 में 1 1 1 वी के करस्पॉन्डिंग, वी के करस्पॉन्डिंग 1 1 1 कहां मिल रहा है, 1 to 5 में। सो जो आउटपुट रिस्पांस आपका ग्रेड रिलेशन का है, उसको मैं समेशन करूंगा 1 to 5 रिस्पांस का एंड टेक द एवरेज ऑफ दैट, दैट एवरेज विल गिव द फर्स्ट एवरेज। सिमिलरली फॉर जब मैं टीआर के लिए कैलकुलेट करूंगा, देन क्या होगा, लेवल 1, तो लेवल 1 यहां है फर्स्ट नंबर पे, फिर लेवल 1 कहां पे, 6 नंबर पे है, फिर 11 नंबर पे है, फिर 16 नंबर पे है, फिर 21 पे है, राइट? सो जहां जहां पे 1 है, उसके करस्पॉन्डिंग जो आपका ग्रेड रिलेशन का वैल्यूज होगा, उसका एवरेज लेना है आपको, दैट विल गिव टीआर 1। फिर n के लिए जब मैं निकालूंगा, तो n के लिए फर्स्ट 1 कहां पे आपका 1 नंबर पे है, सेकंड 1 कहां पे आपका 10 नंबर पे है, थर्ड 1 कहां पे आपका 14 नंबर पे है, फोर्थ 18 पे है और 5 22 पे है। तो करस्पॉन्डिंग वैल्यू ऑफ ओवरऑल ग्रे कोफिशिएंट विल बी टेकन एज एवरेज, राइट? इन द सिमिलर वे फॉर सेकंड लेवल जब बात करेंगे, जहां जहां 2 है उसके रेस्पेक्ट में, उस पर्टिकुलर पॉइंट का रेस्पेक्टिव वैल्यू ऑफ ओवरऑल ग्रे रिलेशन कोफिशिएंट निकालेंगे और उसको हम ऐड करके एवरेज कर लेंगे, सो यू विल गेट दिस टेबल। तो ये टेबल आपका प्रिपेयर हो जाएगा। एंड डेल्टा मींस द मैक्सिमम एंड मिनिमम का डिफरेंस, उसको बोलते हैं हम रेंज। तो इसका जो मैक्सिमम मिनिमम का डिफरेंस है, उसको हम रेंज की तरह कैलकुलेट कर सकते हैं। ओवरऑल मीन भी इसका आप निकाल सकते हैं। अब आपके पास ये डेटा हो जाएगा, फिर इस डेटा को आप प्लॉट करोगे विथ रेस्पेक्ट टू वी के लिए अलग प्लॉट करोगे, टीआर के लिए अलग प्लॉट करोगे, एन के लिए, डब्ल्यूएफ के लिए, सीआरएफ के लिए जब आप डेटा प्लॉट करोगे, देन यू विल गेट द रिस्पांस ग्राफ लाइक दिस दैट वी हैव डिस्कस्ड इन यस्टरडे लेक्चर आल्सो। और यहां से फिर जो जो कॉम्बिनेशन आपका मैक्सिमम मिनिमम मैक्सिमम आता है, वो पिक करके आप इसका ऑप्टिमम कॉम्बिनेशन बताएंगे। एम आई क्लियर?
Yes, sir.
Can you able to connect it from
yes, sir.
starting till date, whatever we have discussed?
yes.
अब इसमें इंपॉर्टेंट पॉइंट क्या है, जब इस पेपर को आप पढ़ोगे, राइट, अननेसेसरी का इसमें एनोवा वगैरह लगा दिए गए जिसकी जरूरत आपको नहीं थी। आप सीधा सीधा रिस्पॉन्स देख के बता सकते हो कौन कौन सा चीजें कहाँ पे निकल सकती है, कौन सा सिग्निफिकेंट फैक्टर है, कौन सा नहीं है। इज नॉट रिक्वायर्ड इन ऑल दोस थिंग्स। बट स्टिल ओके, ठीक है, इस इन टर्म्स ऑफ लोगों ने बनाया है, बट इसको आप चाहे तो और शॉर्ट में इसको सॉल्व कर सकते हैं। मतलब इस टाइप के आप पेपर उठाइए, इस मेथड को अप्लाई करिए एंड ट्राई टू सॉल्व दैट। कुछ जगहों पे ऐसे भी होंगे जहां जहां जैसे मैंने बोला आपको 2 एक्स्ट्रा टेबल अननेसेसरी दिया हुआ है, वहां आपको घबराने की जरूरत नहीं है। आपको क्या चाहिए वो टारगेट करिए। जैसे मुझे ग्रे रिलेशन, इंडिविजुअल ग्रे रिलेशन कोफिशिएंट चाहिए, इंडिविजुअल ग्रे रिलेशन कोफिशिएंट के लिए आपको जो जो चाहिए रिस्पांस टेबल को उठाइए और मेथड हमारा यूज करके सॉल्व करिए जो हम डिस्कस किए, और आंसर देखिए मैच हो रहा है कि नहीं। No need to go step by step using paper. Am I clear? पेपर में जो किया है वही फॉलो करना जरूरी नहीं है। आपको क्या चाहिए, इट इज योर ओन थॉट प्रोसेस, राइट? तो अननेसेसरी के टेबल को आप अवॉइड कर सकते हो। टाइम टू आप सीधा सीधा इक्वेशन लगाइए, उस इक्वेशन को यूज करिए, डायरेक्टली 2 टेबल आप छोड़ के सीधा लास्ट टेबल में आ सकते हो। फाइन। So this is the one example I have taken for gray relation coefficient. I think I have discussed sufficiently from my side about this topic, right? Any other query from your side, please let me know. Otherwise, I will stop here today. Any query from your side?
Sir, this method we were talking about, we did not talk about nominal the best. Only this is applicable for lower the best and higher the best, no sir?
Yes, yes. जब हम नॉमिनल वो लगाते हैं तो आपका डिजाइबिलिटी अप्रोच पे जाना पड़ता है.
Yeah, we have to. That has to be.
Yes, of course. Nominal is better and जो target is better वाला जो concept है, that is used for the desirability approach.
Okay.
Okay.
Okay, sir. Thank you. Thank
Any
you,
other
sir.
queries, please? So should I stop? Hello.
Sir,
Yes, sir, please.
sir, I think doubts of students have already been cleared by.
Yes.
So, should we conclude today's session, sir? With due consent?
Yeah. No query from, I think I am done with my time. Okay.
Sir. So, Honorable, I think it's. Just a minute. So, audio problem is there.
Cell phone, if it is switched on, it has to be kept at a distance, sir.
Is it audible to all of you?
Yes. Now there is
Yes,
no
yes, sir.
disturbance.
Sir. So, a big thank you to Dr. Dilip Kumar Gupta ji, Assistant Professor, IIT RAM, for his efforts towards gray relation analysis and utility function approach, particularly on the topic of gray relation analysis. Had been an area in which very less practical knowledge is available on the internet, and even if it is available, then also such detailed knowledge is not provided. So I again thank him. Thank you very much, sir. And I request all the participants to join for tomorrow's session in the morning at 10. Thank you. Thanks to all of you.
Thank you, sir.
Okay, thank you, sir.
Thank you, sir. Thank you.
Thank you, thank you.
Thank you very much, sir.
Thank you, sir. Thank you, sir.